We are going to continue to solve square roots today. And remember from last time that there's really broadly 4 steps to these problems. First, isolate the square root. Second, square both sides. Third, solve the equation. Fourth, check the solutions. And in general, that's a path that should work nicely. In this problem, the square root of x minus 1 plus 1 equals x, we need to isolate the square root first by subtracting 1 from both sides. And this will give us the square root of x minus 1 equals x minus 1. Now that we've isolated the square root, we can square both sides. When you square a square root, on the left we would get just x minus 1. On the right, you need to remember, I'm going to write it out in a little extra detail, that x minus 1 squared means x minus 1 times x minus 1. And you could use FOIL or distribution to multiply these out. But when you do, you will get x squared minus 2x plus 1. Now in this case, and maybe how this problem differs from things previously, is we have this x squared term, which means that this is a quadratic. And our methods of solving quadratics to this point involve getting it equal to 0 first. So I'm going to subtract x from both sides and add 1 to both sides in order to get this equal to 0. Right? Our tools for solving quadratics at this point remain factoring, although somebody else may have some other tools. X squared minus 3x plus 2. Well, if we use the AC method, this would have come from x squared minus 1x minus 2x plus 2. And using grouping, this would be x minus 1 minus 2 times x minus 1, which means that this factors into x minus 1 times x minus 2. And I'm running out of room here, so I'm going to move inconveniently up and to the left. I would need to send both of these factors equal to 0. X minus 1 equals 0. X minus 2 equals 0. Which means that x could equal 1 or x could equal 2. So we finally solved this equation. But now we need to check our solutions, which means going back to the beginning. So the original equation, this would be 1 minus 1 plus 1 equals 1. The square root of 0 plus 1 equals 1. The square root of 0 is 0. So 1 equals 1. X equals 1 checks out. We've got to check our other solution. The square root of 2 minus 1 plus 1 should equal 2. The positive square root of 1 plus 1 should equal 2. 1 plus 1 does equal 2. This checks out. In this case, both 1 and 2 are solutions to the problem. Right, there's a lot going on in this problem. We're pulling a lot of different ideas together. Why don't you try one? Why don't you try the square root of x minus 2 plus 2 equals x. Hit pause and give it a shot. Alright, if we subtract 2 from both sides, we get the square root of x minus 2 equals x minus 2. Now that we've isolated the square root, we can square both sides. This would give us x minus 2 equals x minus 2 times x minus 2. I'm going to use FOIL to multiply that out and get x squared minus 4x plus 4 when I'm done. Right? You could also use distribution. This is a quadratic again. So I'll subtract x and add 2 to both sides. X squared minus 5x plus 6. This will factor. You could use the AC method. Some of you can see how this is going to factor. But however you factor this, this is going to factor into x minus 2 times x minus 3. Which means that x minus 2 could equal 0, or x could equal 2. Means that x minus 3 could equal 0, or x could equal 3. So we have our two possible solutions, but we always have to check them in square root problems. If we plug in 2, the square root of 2 minus 2 plus 2 should equal 2. Well, this is the square root of 0 plus 2. Square root of 0 is 0. Oops. So 2 equals 2. This checks out. X equals 2 is a solution. We've got to check x equals 3. The square root of 3 minus 2 plus 2 should equal 3. Positive square root of 1 plus 2 should equal 3. 1 plus 2 does equal 3. This checks out. In this case, both 2 and 3 are solutions. Be real careful with your work. A lot of places that make silly mistakes, but I know you've got the skills to do it.